Ladies and gentlemen of Algebra 2, welcome to the end of Unit 4. We're looking at 4.7, the quadratic formula. So what that means is this. When graphing doesn't work, when factoring doesn't work, when everything else sucks, you try this and see if this will give you at least a workable answer. So the reason we talked about imaginary and complex numbers was because sometimes those numbers show up in the quadratic formula. So you need to be able to learn the quadratic formula. You need to memorize the quadratic. So if I take a look, competitors at 10-meter platform diving competition jump upward and outward before diving into the water below. So this 10 represents that they start off 10 meters above the ground. The 4.9, negative 4.9 is gravity in terms of meters. And 3 is kind of what your average, how much they jump off, how much power they jump off the board with. So can you solve by factoring? You can try, but you're going to be a big mess. Can we solve by graphing? You can, but I wouldn't do it without a calculator. What I would do instead is go after using the quadratic formula. So quadratic formula right here. So if I've got a quadratic ax squared plus bx plus c equals 0, where a does not equal 0, you look at this and go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, there is a song like that. And you can YouTube, there's about 80,000 different versions out there. But listen to a couple of them and that will help you. So now, this little part underneath, the b squared minus 4ac, that has got a very distinct name. This part is called the discriminant. All right, and what the discriminant is this. The discriminant tells you how many answers you should have. It doesn't tell you what they will be. It doesn't tell you what they are. It just tells you how many answers you should have. So, 3 things can happen with the discriminant. So here's kind of what happens. It's bigger than 0. If it's positive, that means that there are 2 real solutions. All right? If it is equal to 0, that means there is 1 real solution. If it is negative, that's what less than 0 mean. If it's negative, that means there are 0 real solutions. Okay? And there's a couple of examples. Then if you look, this is what the graph will look like. Those are the differences in the graphs. Notice, for 0 real solution, it never crosses the x-axis. That's why there's no real solutions. So that's kind of what you're looking at. So right here. So 2, 1, 0. So take a look at this, circle it, put stars by so you understand it. So maybe a song would help, but like I said, you can YouTube that and get as many versions of the song as you wish. I might throw a couple into Schoology just for fun so you can look there as well. So let's kind of get into it here. Solve using the quadratic formula. I was very nice and put it up in the corner for you, right here. So, but the first thing I need to do is make it equal 0. So I'm going to subtract 28. So I'm going to have x squared minus 12x minus 28. So that's going to be here. So a will be 1, b will be 2, c will be a negative 12, sorry. So x equals negative b. So it's going to be negative 12 plus or minus the square root of 12 squared minus 4 times 1 times the negative 28 all over 2 times 1. So obviously, order of operations plays a big role in here. So if I put this together, keep the negative 12 plus or minus, that's 144 plus, because I've got minus here and a minus here, 4 times 28 is going to be 112 all over 2. 144 plus 112 is going to be 256 all over 2. So, square root of 256 is going to be 16 all over 2. So now, 2 versions. So split this. negative 12 plus 16 over 2, negative 12 minus 16 over 2. So once again, x squared, you always got two versions, so this is going to be 4 over 2, so this is 2. Negative 12 minus 16, that's going to give me negative 28 over 2, so negative 14. So my solutions there are going to be 2 and negative 14. Okay, now, big important points. Make sure that you are very stingy about putting things in the right spot and that your signs match up. And then you've got to be very diligent with order of operations to arrive at those answers. So if I look here, A would be 2, B would be 4, C is going to be negative 5. So following the quadratic formula, we're going to go negative 4 plus or minus square root of 4 squared minus 4 times 2 times a negative 5 all over 2 times 2. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So that gives me 16 minus 4 times 2, which is 8, times negative 5, which is going to be 40, over 4. So now I know right away that 56 does not split well for me. Okay, 56 is not a perfect square root. So what I can do then is this. I can simplify square root of 56. Sorry, square root of 56. Let's split that. I know it can be divided by 4. So that's going to give me 4 and 14. So square root of 4, square root of 4, that'll be 2 square root of 14. So I can rewrite this as negative 4 plus or minus 2 square root of 14 all over 4. So now I can take this, this, and this. I can divide all those by 2, and here's what I will get. I can go negative 2 plus or minus just the square root of 14, because the 2 gets divided by 2, which is 1, and then 4 divided by 2 is 2. Then this would be considered a good answer. This would be fine. Okay, this would be a simplified answer. All right? Yeah, you can throw it in your calculator, get a big, long, ugly decimal. Yeah, okay, whatever. That's not simplified. This is considered simplified. The big, long, ugly decimal is considered to be rounded, considered to be approximate, because the decimal goes on forever and ever and ever. This is considered to be the simplified answer. All right, fully simplified answer. I took everything out that I could. So here, what's A, what's B, what's C? Well, A is 3, B is 5, C is 4. So let's see kind of what happens here. This could be interesting. Because I want to go negative 5 plus or minus square root 5 squared minus 4 times 3 times 4 all over 2 times 3. So let's play the order of operations game, and I'm going to get negative 5 plus or minus square root 25 minus 4 times 3 is 12 times 4 is 48 all over 6. So now if I put this together, that's negative 5 plus or minus 25 minus 48 is going to be a negative 23 over 6. Now, there's nothing I can do with that negative 23, but if I look back at my discriminant notes, this is less than 0. That means that there are no real solutions. What I mean when I say that is that this number is negative. So this would be my answer, but I got to realize that that means there's no real solutions. If I graph this, it's never going to touch the x-axis. That's that relationship, is that those two are never going to touch. So that would be my solution, but I got to realize that there's no real solutions. So if I take a look here, path of a football thrown across the field given by this equation, 0.005 x squared plus x plus 5, where x represents your distance in feet And y represents the height in feet above ground level. How far has the ball traveled horizontally when it travels to the ground? So basically, I want to run quadratic formula on this, where a is my negative 0.005, b is 1, c is 5. All right, so when I throw this in here, that's going to be negative 1 plus or minus square root 1 squared minus 4 times 0.005 negative times 5, all over 2 times negative 0.005. Now, I know this looks like a big mess. Trust me, let the calculator do some of the legwork, and then you'll kind of see what happens, and it'll kind of work itself out, especially with the signs. So 4 times negative 0.005 times 5, and that's going to be 1 minus 0.1. 2 times negative 0.005 is going to be negative 0.01. So I'm going to be left with negative 1 plus or minus square root of 0.9 over negative 0.01. So square root of 0.9 is something different. So if I run this, now I'm going to run both of them. So I'm just going to run them both through the calculator. I'm going to go negative 1 minus square root of negative 0.9 over negative 0.01. And again, I'm letting the calculator do a lot of this. All right, so I'm going to go negative 1 plus square root of 0.9 divided by negative 0.1. And that gives me positive 513.167. If I go negative 1 minus square root of 0.9 divided by negative 0.1, I get 19.4868. So these are my two answers. So now back to my original question about how far has a ball traveled horizontally when it returns to the ground. Well, it has traveled about 20 meters, okay? So about 20 meters. 20 meters is approximately 60 yards. So it's going to be about 19 meters, 19 and a half meters. So not quite 59 to 60 yards, or feet, sorry. Screw that one up. Just go with 19 meters. It's easier that way. All right, so last one. Object is shot upward in the air with initial speed of 800 feet per second. The height h that it reaches will be after 10 seconds is given by this equation. When will the object reach a height of 10,000 feet? So what they're saying is, when will this thing equal 10,000 feet? So this is what I'm trying to solve. So first off, let's make it equal 0. So subtract 10,000 over. Now, I can do the quadratic formula right here. But before I do that, I want to see if I can divide some things here. So 800 divided by 16, that works. So if I kind of divide everything by a negative 16, that is just going to make my life way easier. Right side is still 0 because 0 divided by anything is still 0. Left side, this becomes positive t squared. This becomes a negative 50t. This becomes a positive 625. So now let's attack this because this is way easier, and this is also the equivalent. What I want to do is kind of that same idea. A equals 1, B will equal negative 50, C will equal 625. Yeah, I know 625 is still kind of big, but it is significantly easier to deal with than 10,000. So let's work with that. So setting my problem up, so that's going to be a negative 50 plus or minus square root negative 50 squared minus 4 times 1 times 625 all over 2 times 1. So now, what happens here then is this. When I start to put this together, put these pieces together, I'm going to get positive 50 plus or minus. And then negative 50 squared is going to give me 2,500 minus 625 times 4, which is going to be 2,500 all over 2. Well, notice this goes to 0, doesn't it? So this becomes 50 plus or minus 0 over 2. So that completely goes away. So my answer just becomes 25. So 25 is my answer. So if I go back to the original part of the problem, when will the object reach a height of 10,000 feet? It's going to be 25 seconds. And what I also need to remember is that that's also going to be the highest it ever goes. So it's going to go up and come back down. Then that highest point, that's going to be 10,000 feet. And it's going to be at 25 seconds. All right, play around with this, memorize this, come back and talk to me with questions.